Okay, so when you have radicals, what do you think a common technique is? Square both sides. And the unfortunate thing about radicals with these, when you square both sides, you might introduce extra answers. Remember when we had to do the checking thing with those absolute value equations? Does that ring a bell? Where we had like absolute value of something equals an x on one side. And so in this case, you're going to have to also check.
Yeah,
so
you have to check one side.
You've actually got to check your answers. And it is the case that they could both work, one could work, or none could work, and you'd have no solution. So, but the basic idea that, okay, yeah, you square both sides is the good place to start. So when you square both sides, you get x squared equals what? X plus 2. And so probably going to solve by factoring, right? So move the x and the 2 on the left. You get x squared minus x minus 2 equals 0. And then that factors pretty easily, doesn't it?
Yep.
Yeah, into x.
Minus 2.
Yep.
X plus 1.
Yep. And so one answer is 2, or one potential answer is 2, and one other potential answer is negative 1. Okay, so when we check them, check please, does 2 equal root 2 plus 2?
Yes.
Yes, so that one works. Does negative 1 equal root negative 1 plus 2?
No.
No. Negative 1 equals root 1, and root 1 is defined to be just 1, so no. And the reason this happens is when you square, you kind of lose some information about the negatives. So when you see a root thing, you're probably going to always have to check. And there isn't a hard, fast rule. Like, it is completely possible that one answer works, both could work, or none could work. And if none work, then it's none of your two answers work. Two things happened. You did it wrong, or it is no solution.
Well, if you have the side that's not the square root, if that side's negative, then you know it's not going to work.
Yeah, but there are other situations in which it wouldn't work as well. Okay, so how about, so same idea, square both sides. I'm going to make a mistake on purpose. What did I do wrong?
You missed the middle term.
I missed the middle term, right? So everybody knows, so you guys should all know x minus 5 squared isn't x squared plus 25, right? So the part that's wrong was this part. What should it have been instead?
X squared minus 10 plus 20, well, minus 10x plus 25.
X squared minus 10x plus 25, very good, yep. So x squared minus 10x plus 25. If you make a mistake, that's one thing it's going to be. So if you all know how to, I mean, it's common that when you know how to square, but then having to square middle of the problem's a little bit tricky sometimes. Okay, now how about you move the x over to the left and move the negative 3 over to the left. What do you get? Uh-huh. Great. X squared minus 11x plus 28. And hopefully that factors.
It does.
Yay! 7 and 4?
Yep.
So that factors into x minus 7 times x minus 4. And one potential answer is 7, and one potential answer is 4. When checking, plug into original. Does that make sense as well? Okay, always the original, because the place where you introduced extra answers like happened somewhere in one of the first steps. So let's try 7. So does 7 minus 5 equal square root of 7 minus 3? Does that work? It appears to, right? 7 minus 5 is 2, right? 7 minus 3 is 4, then your root, you get 2. So I just care that you, like, show me you've checked somehow, right? How about 4? Does 4 minus 5 equal square root of 4 minus 3? No. So what you could do two things. You could just only circle the one that actually is the solution, or just totally cross out the one that actually isn't. So it's totally obvious you don't know, you think that that's not a solution.
Well, is negative 1 not the square root of 1?
It's not, yeah. So that is a technical thing. But when I give you square root of a number, it always means the positive one. And it's because the square root is a function, so one input goes to one output. So for it to give you the negative, it has to be negative square root of 1. Does that make sense? That's a technicality. Okay. Sometimes you have to square twice. And it's a bit tricky. So you're like, So if you looked at this, what would be your first instinct as to what you should do?
Square.
Now, is it legit to do like this? No, that's not okay. That's the same thing as saying a squared distributes. So that's out. I think it would probably be easiest. So do you really want to do like this whole big thing multiplied by itself? No. So what I would think is the best thing that I can do is get one square root by itself. Does that make sense? So like write it as root 2x plus 5 equals 5 minus square root x plus 2. And then at least when I square the piece on the right side, at least I'm not squaring a root plus a root, right? It seems like I might be able, and one root's gonna go away, right? So take this expression, and we're gonna square this, and we're gonna square that. So that gives 2x plus 5. I'm actually gonna write this one down, like a lot of the steps. 5 minus root x plus 2 times 5 minus root x plus 2. Is everyone okay with what I'm doing? You can cry because it takes half a page paper, okay? Like you're allowed to do that, but. Okay, so that's 2x plus 5. Now, what do you get when you're distributing on the right side? First, we'll have 25 minus how many square roots of x plus 2? 10. And then the one tricky thing, that comes from multiplying root x plus 2 times root x plus 2, right? What did I forget? Yeah, this needs to be in parentheses. Does that make sense?
What is a negative times a negative?
Yeah.
And it should be positive. I forgot two things. Sorry. Okay. All right, well, that's at least, it's at least 2x plus 5 equals, let's see, what is it? X plus 27 minus 10 root x plus 2, right? Does that make sense? And you're thinking, well, at least I can get the x's and the constants together, right? So take away x, and you get x on this side. Take away 27, and you get
Minus 22.
minus 22. And at least at this point in time, you have successfully killed off one of the square roots, right? So now what could you do?
Divide by -7.
I would avoid fractions if at all possible. I would square everything. Does that make sense? So square this. Feel free to use a calculator for humongous numbers if this happens, okay? That becomes x squared minus 44x. I don't have 22 squared memorized, but my notes say it's 484. Equals 100 times the quantity x plus 2. Okay, so that's x squared minus 44x plus 484 equals 100x plus 200, right? Man, so x squared minus 144x plus 284, right? Okay. I know it's painful. And you're hoping like, oh my gosh, please factor, please factor. And please factor and be an easy factor, right? I don't know the factors of 284, but what is 284 divided by 2? Yeah, 284 divided by 2 is 142. Why is that helpful? Yeah, so 142 and 2 makes 144, right? So this factors into x minus 2, x minus 142. Somebody tried real hard to make this problem work out and have pretty answers. And so you get x equals 2 and x equals 142. Now that stage, you're so done, you don't want to even check your answers, do you? No, but checking isn't very hard, is it? So we'll check 2 first. Okay, so you plug in 2, you get root 4 plus 5 plus root 2 plus 2 equals 5. Does that check out or not? Yes, it does. Okay, great. When you check 142, holy moly, okay, so 2 times 142 is 284 plus root 142 plus 2, does that equal 5? It doesn't take a calculator to tell you that that's not going to work, right? You're going to have like humongous numbers equaling 5. No way. So that's not an answer. And I realize that every example that I've done has had exactly one of the answers work out. It is not always like that, so don't be fooled. Sometimes both answers will work and sometimes none will work. When we talk about graphing functions, I can explain another way to understand why. Okay, so absolute value equations. So you had something like this on your quiz, I think. I wrote the quiz a long time ago, so I kind of forgot. But the way that we solved stuff like this was by making 2 equations. Does that ring a bell? Mm-hmm. So the first equation that you solved was the obvious one. It was that, well, 3x minus 4 equals x plus 4. What was the other equation that you solved?
3x minus 4 equals minus x minus 4.
Equals negative x plus 4, which Daniel went ahead and already distributed as 3x minus 4 equals minus x minus 4. So for the first one, we get 2x equals 8. Does that make sense? Was that too fast?
No.
And then x equals 4. The second one we get 4x equals 0, so x is equal to 0. Do they both work? So when you plug in 4, you get the absolute value of 12 minus 4 equals 4 plus 4. Does that check out? Yes, so 4 is a legit answer. When you plug in 0, you get the absolute value of 0 minus 4 equals 0 plus 4. Does that one work? Mm-hmm. Yes, okay, great. So both answers worked. Sometimes one will work, sometimes none will work, but in that case both of them did. So that's still a legitimate way to solve these equations. There is another way. The other way you can solve this is by squaring both sides. Because, if you have a negative, squaring both sides will sort of get rid of the whole plus minus thing, right? So if you square both sides, you can kind of say, oh, the absolute value, then that squared is going to be the same thing, because if it's a positive or negative number, they'll square to the same thing. So you can square this side and square that side. We're going to get the same answers. So on the left, you're going to have 3x minus 4 equals, what is x plus 4 squared? So we're doing this the second way is to take this expression and square both sides.
So if it's in an absolute value.
If it's in an absolute value, the whole thing that's funky with absolute values is they equal two different things. They equal positive the number or negative the number, right? And one way to deal with that and sort of make the negative go away is to square both sides.
Because isn't a absolute value kind of like radical?
Yeah, and that's also a thing. Remember how we also said the absolute value is kind of like a square root of something squared, right? What was the order specifically that did matter? It was the...
So just like any time, just treat it like a radical.
Yeah, you can treat it like a radical. And the other method is still legitimate and fine. Like, it still works. It's not wrong. It's just that another way to do it is to square both sides. And it will also work. And I just want to show you that it actually happens. So 3x minus 4 will equal, what does x plus 4 squared become?
X squared plus 8x plus 16.
And holy moly, I'm an idiot. If I have 3x minus 4 squared, I have to do 3x minus 4 multiplied by 3x minus 4, don't I? No wonder you were confused, because I was being stupid. I'm so sorry. So this should be 3x minus 4 squared equals x plus 4 squared. I'm so sorry. Math at 8 a.m. Okay, so that's 3x minus 4 times 3x minus 4. And Natalie, you said what the other side was. Could you tell me again?
X squared plus 8x plus 16.
Mm-hmm. I only wrote the stuff out on the left to show you that pattern there, just because it's a little bit more tricky. That's 9x squared. And then does it make sense you're going to get minus 12x and minus 12x again? So minus 24x plus 16 will equal x squared plus 8x plus 16. And you think, oh man, I have x squared, it's multiple things. Do you want to put all the stuff on the left or all the stuff on the right? Left. So 9x squared minus x squared will make?
8x squared.
Uh-huh. Will you take away 8x or add 8x?
Take away.
So 24 minus 8, if it's 24 degrees below 0 and goes down 8 more, we're crying, it's minus 32. And what happens if you take away the 16s? 0. Okay, so equals 0. And then there probably is a greatest common factor, right? 8. Mm-hmm. And one thing is 8x equals 0, so x is 0 is an answer, and x equals 4. You would need to check, but why don't we have to? Yeah, we already have, right? We checked them for the last one. It's like if you were doing this problem on its own and you hadn't already checked because you did it 2 ways, you would have to check them. So I don't really prefer, I kind of prefer the first method because it's the way that I learned first, but this also works. If you want to do it this way, you totally can. All right. Now the next thing is legitimately, I think, a little bit hard, but the idea of what happens here does come up in calculus. So one idea that comes up in calculus towards the end of the class is you take these things and you try to make them look simpler so that you can actually use techniques you know to solve them. And we're going to apply a similar idea to factoring. So how is this factoring problem different than the previous ones we've seen? X is raised to the 4th. Does that make sense? That's a little bit weird. We've only had x squared, right? Yeah, so one thing that you can do is you make a substitution and you say, well, I'm going to let something, and the letter usually is u equals x squared. And if u is x squared, does it make sense that u squared is x squared squared or x to the fourth? Does that idea make sense? So what you can do is, if u squared is x to the fourth, you can replace the x to the fourth by u squared. That becomes 13u plus 36. And then develop temporary amnesia and forget the original problem existed and just solve the second one. So can you factor u squared minus 13u plus 36 equals 0? Yes, Willow?
Couldn't you still factor the top one, just by keeping track of it?
Yeah, so can I do that at the end? Yes, definitely. So you'll have u minus 9, u minus 4. Does that make sense, guys? Yes, no, okay. So you're going to have u equals 9 or u equals 4, right? And then your u was equal to x squared, right? So that's x squared equals 9 or x squared equals 4. And so what are if x squared is 9, there are two answers for x there. What are they?
3 and 2.
Plus and minus 3. Don't forget your plus minuses. And the other one is x equals,
Plus or minus.
yep.
So you actually get 4 answers.
Yeah, and I don't know if you guys learned this in algebra too, but I taught my students this, that the number of answers you get with a couple technicalities is almost always equal to the highest power. Does that make sense? And there's something called multiplicity where you get answers more than once, in which case it always matches. So that can be a hint. Okay, now Willow had another method that is also legitimate and a bit faster. So she said, couldn't you do this just by keeping track of the exponents? And she's right. I think what she meant by that is you could think, well, x to the fourth, it had to come from x squared and x squared. Is that what you were thinking, Willow?
Yeah.
And then she's like, okay, well, now we have to multiply to 36, so minus 9 and minus 4. Does that make sense? It's the same thing? And so then she would get x squared minus 9 equals 0, x squared minus 4 equals 0. And so she'd still get x squared equals 9, and she'd get the same answers, right? If you want to do it that way, that's totally fine, okay? Like, that's not a problem. There are some slightly more complicated ones where knowing the substitution idea is important, but honestly, once you get good, it's totally okay to just keep them with x's and use that pattern. Does it also make sense to everybody else that this, oh, it doesn't work to erase it when I have to, oh, bummer. Okay, well, whatever. Let me write the original problem over, that'll be fastest. So the fact that this worked was very dependent upon the pattern in the exponents. Would this have worked if that would have been a 13x? Does that make sense? Like, if this had been x and not x squared, would the whole factoring thing have worked? It wouldn't have, right? And that's one thing that I think the substitution makes a little bit more clear, because this depended upon you being able to replace that thing by a u and not some u to a funky power. So these problems are sort of doctored to work out special, and the pattern is that this number, this power, has to be half of that one. It's like if this were a sixth and that were a third, it would also work. So we'll do some more complicated ones, but that's kind of the most basic one. Okay, holy moly, this one. Does this one factor? I don't think it does. So let's do the substitution just to practice. You'll let u equal x squared, right? So u squared is x to the fourth. That becomes 2u squared plus 3u minus 4 equals 0. Does this one factor? I don't think so. You try to do that like trick where you multiply the 2 and -4 and you get -8, right? Do any factors of -8 add to 3? Here, no, okay. So now solve using the quadratic formula. You're gonna have u equals negative b, so -3, plus or minus the square root of b squared, which is, Gesundheit,
9.
9, great, minus
32.
4 times 2 times -4. I'm just not as fast as you are. All over 4. I think I have short-term memory loss. -3 plus or minus the square root of, you said 32? Do you guys
No.
agree with him?
9 plus.
Oh, you said 9 plus 32. I see. The 4 times 2 times the 4 was 32. Yes, So square root of 41 in that case, yes? Okay, over 4. So is that your final answer?
I think so.
But it's u equals, not, and the original thing had x's in it.
So you have to square it.
So it's really x squared equals that stuff. And is he right when he says you have to square it?
Square root.
To square root it, yeah. So x will equal plus or minus the square root of all that stuff. I don't think you have to simplify that any more than it already is.
Well,
You could say over 2, right? That would be okay. That would be easy to do. So Willow, if you didn't want to make the substitution, you would just have to start here by saying that that's x squared equals, and it would be the same thing. You guys understand what I meant by that? Okay. So hopefully Alex doesn't want you to, and does that make sense that that's also actually 4 answers?
Yeah, because you have 2 plus or minus.
Yeah, so you've got the positive one where this is also positive, positive one where that's negative, the negative one where that's positive, and the negative one where that's negative. Some of them are going to be imaginary answers. You're going to have a negative inside that radical sign. That's really ugly and won't come up very often, but it's just good to be aware of the whole substitution pattern kind of thing. Okay, so here's a couple trickier ones. So would substitution work for these, and what is the substitution? So we didn't do any harder ones. Let me write down one that's a little bit simpler. I'll write down, we'll call it letter Z. Let's say x to the 6th plus 2x cubed plus 1. What would you substitute for that one? U equals x cubed. And how you can tell then is u squared is x cubed squared. What happens to those powers? They multiply, they get x to the 6th. So the pattern is that the middle exponent, when you arrange them, well, kind of from biggest to smallest, but that's not quite true of these next ones. This is half of that, right? Is the same pattern true for this A one?
Yes.
Yeah, so what you could do for this one is you could let u equal x to the -2. Does that make sense? And then u squared will be x to the -2, the whole thing squared, and what does that make? X to the -4. So that's your substitution. The answer is yes. This becomes 3u squared plus 2u plus 7 equals 0. Using that u. Which if you can keep proper track of it, you could say, you know, it's going to be something with x to the -2 and x to the -2. It's also totally fine. Could you make a substitution and do part B?
No.
No. How about part C?
I think so.
Yeah, here's how you can really tell. Does it make sense that root x is x to the 1/2? So if you have x squared times x to the 1/2, what happens in the powers?
Yeah.
They add, so 2 plus 1/2 is 2.5, right? So 4x to the 2.5 minus 6 equals 0. So is the halving pattern there present? So the substitution you'd make would be u equals x to the 2.5. And that'd be 2u squared plus 4u minus 6 equals 0. So you can choose if you do or do not want to actually use the letter u and substitute. Yeah.
Could you also think of the first term being two x squared root x?
Yes, yeah, you could think about the first term as 2x squared root x squared. You could think about it like that.
Yes.
Yes. So you could think that that first term is 2 times the quantity x root x squared. Is that what you're thinking? Yep, exactly. You totally could. Okay. Yeah.
For B, why couldn't you sub it in?
Because this subbing pattern depends upon this thing being the square of that thing. So what will, in order for the pattern to work, you have to be able to, and I think I wrote that a little wrong, Willow. This should have been squared right there. So, yep. If you take this thing and you square it, you should get that. Otherwise, the pattern won't work. Okay. All right, so here we go. Your book had this one first, and I thought fractional exponents are a bit tricky, so. Yeah. So let's actually make the substitution. If you don't like it, you can also do it the other way. So what would you possibly substitute here? X to the 1/3, yep. And then u squared is x to the 1/3 squared, and what happens to those powers? They multiply, right? What's 2 times 1/3? 2/3. So that thing's replaced by u squared. This thing is replaced by u, and the 6 just stays. And the idea of substitution comes up in calculus, but it's in a different context. It's not like with these equations. So does that factor? Yeah, u minus 3, u plus 2, right? So if I say u equals 3 and u equals -2, does that make sense? Okay. So x to the 1/3 equals 3, and x to the 1/3 equals -2. And how do you undo a power of 1/3?
Cube.
You cube it, right? Because it really is a cube root, so the opposite is cubing. So this will give you x equals 3 cubed, or 27, right? X equals -2 cubed, which is almost -8. So if you had skipped the substitution and gone straight to the factoring step, you would have factored into x to the 1/3 minus 3, x to the 1/3 plus 2. Does that make sense? Okay, so if you think you like that, you can also do it that way. We could do the next one that way, for example, just for kicks. Okay. So is the whole halving pattern present here so we can do this? Yep, okay, so in that case, if you did a u, you would let u equal x to the 1/4, right? Okay, so if you do it the other way, if you just factor off from the get-go, what's going to go in the first spot? X raised to the 1/4. And you can think, okay, x to the 1/4 times x to the 1/4 is x to the 2/4, which is 1/2, right? And then what numbers go elsewhere? -2 and -3. That way is faster, isn't it? So if you can handle it that way, like, it'll save you some time. And so you'll have x to the 1/4 minus 2 equals 0. X to the 1/4 minus 3 equals 0. So x to the 1/4 equals 2. And how do you undo that fourth root? raised to the power of 4, very good. So x will equal 2 to the power of 4, which is 16. Great. And this one will be x to the 1/4 equals 3. X equals 3 to the 4th, which is 81. Great job. Should I show you what the substitution would be as well? Do you want to see? Okay. If you did this substitution, does it make sense that u squared is x to the 2/4 or x to the 1/2? So if you substitute, you're going to end up with u squared minus 5u plus 6 equals 0. And my guess is you could get it from there, right? Does that make sense? Yeah, okay. So either method's fine. I don't know what you guys prefer, and my guess is like half of you prefer one, half of you prefer the other. So, no, this second way, the one that Willow suggested, is definitely faster once you get the patterns down. So I would suggest beginning with the substitution thing if you're a little bit confused, but always trying to ask yourself, like, okay, how could I have skipped that and gone like straight to the factoring step? Okay, and then just some random stuff. So, random stuff, how would you start this one? Square both sides. So you're going to get x squared equals 5x squared plus 9. So, okay, well, what do you think? So sure, subtract x squared. 0 equals 4x squared plus 9. What else could we do? Minus the 9? What do you think? Okay, negative 9, or the 4x squared, either one. So negative 9 equals 4x squared. Now, do you want to divide by 4, or do you want to take a square root? Square root. Okay, so square root both sides. When you do that, what are you going to have to introduce? I. So we'll say plus or minus 3i equals 2x. Does that make sense? So x equals technically plus or minus 3i over 2. Now there is one technicality here. The only answer that you have is the positive one. Now I don't want you to actually have to check, but the reason is that if you check, so if you check x equals negative 3i over 2, when it goes into this side, it's a negative number, right? And only positive things come out of the thing on the right. So that's why the only answer is 3i over 2. My guess is if you get that close, Alex tells you something like, you have extra answers or you're almost there or something like that. Okay, let's do one more. Put your stuff away already. Here, this you're already done. Okay, so this one, it looks really, really, really nasty and complicated, doesn't it? But if you think, so do you think it would be easier to make a substitution or to expand everything out? Make a substitution, right? And what do you think you're going to substitute for? M squared plus 2m. Yep. So that becomes u squared minus 6u equals 16. Or u squared minus 6u minus 16 equals 0. Does that factor? What, u minus 8 and u plus 2, does that make sense? Okay. So what two things would u equal? Negative 2 and 8. So one thing is m squared plus 2m equals 8. And the other one is m squared plus 2m equals negative 2. And we hope they both be solved by factoring. So first one is m squared plus 2m minus 8 equals 0. Does that factor? Yeah. M, what multiplies to make negative 8 and adds to 2?
4 and negative 2.
Mm-hmm. So one answer is m equals negative 4, and the other one is 2. Okay, we got two answers. Woo! Don't write this down because it's not going to work. When you try to factor this one, does anything multiply to 2 and add to 2? No. So your options are quadratic formula or complete the square. Is this one of the ones where completing the square will work out pretty nicely?
Yes.
Yeah. So what number do I add to both sides?
2.
I think 1. So I add 1 here, and I do negative 2 plus 1 there because I'm going to complete square. That's a bad square. Now it's a square. So that's m plus 1 squared equals negative 1. And I promise I'm only going to go 30 seconds over. So m plus 1 equals plus or minus I. Great. And m will equal negative 1 plus or minus I. Okay, awesome. Okay, so start, if you're going to get the square root by itself, what would you do first? Minus 15, very good. So x minus 15 equals negative 2 root x. And then square both sides. So x minus 15 squared equals negative 2 root x squared. Okay, so that's on the right side we have 4x. How about the left side? X squared minus how many x? 30, good. And then if you don't know 15 squared, I'm not going to judge you. It's 225. No, I think it's actually factors. Okay, so then you take away the 4x, and we get x squared minus 30x plus 225 equals 0.
Minus 4.
Oh, yeah, I was just checking if you guys were awake. This lovely, what is it, Wednesday morning? Yeah, good job. Don't you hate it when you don't write what you mean? Okay, and now you think, oh, phooey, how the heck does that thing factor, right? All right, so what numbers are going to go into 225 evenly?
Negative 9 and negative 25.
Oh man, you're fast. Okay, so negative 9 and negative 25. If you can't get that quickly, you can always revert to the quadratic formula on a calculator, right? So this will factor into x minus 9, x minus 25. That would be really hard to figure out on a test if I didn't give you a calculator, wouldn't it? Yeah. So your answers are x equals 9 and x equals 25. Let's just check them. So does 9 equal 15 minus 2 times root 9?
Yes.
That does, yes, okay. Does 25 equal 15 minus root 25? Or 2 root 25? I think that's 25 equals 15 minus 10, isn't it? So is that true? No. So that one's actually not an answer. So to make it totally obvious to your quiz grader and to me, if you write down an answer that's not actually an answer, like cross it off so I know you don't mean it, okay? Okay. So I would say for questions like this, if you're uncertain if you have to check, you probably should just always check, especially on things like quizzes and stuff. If both answers didn't work, what would the answer be? No solution. Okay, so let's also try this using that substitution thing. So move all the terms onto the side with the x. So write it as x plus 2 root x minus 15 equals 0. What is a square root as a power? 1/2. 1/2. Does it make sense so that then the second power is half of the first power? So what we can do is make that substitution for square root of x. And so then that first x, that's u squared. Right, a square root squared makes x, right? Plus 2u minus 15. And compare that to the previous factoring problem. Which one is harder?
The last one.
The last one. This one's a lot easier, isn't it? So that's going to factor what into u plus 5, u minus 3, is that right?
Yes.
Okay. And so then if I say u equals -5 and u equals +3, does that make sense as well? And so one thing is square root x equals -5. Another thing is square root x equals 3. Does that much make sense? Now the other thing you can tell at this point is that one of these is no solution. Square roots always give you positive answers unless there's a negative in front of it, right? So as it is written, like this thing right there, that is no solution. If you were to square both sides and say, oh, x equals 25, and then go back and check it, you'd have root 25 equals -5, which is not true, right? But you could tell right from the get-go that's no solution. What's the other answer? X equals 9. And I think we checked that that worked in the previous example, right? So this way has two benefits. Benefit one is that the factoring is easier, and benefit number two is that identifying the no solution is also a little bit easier, I think. So if you find that by squaring your answers get kind of complicated, just check and see, can you do this? Also, like Willow was factoring faster yesterday, so if you like her way, you could have gone straight from this step to square root x plus 5 times square root x minus 3. Do you get that's the same thing? Okay. And it's a little bit faster, so if you see that pattern and you want to skip my substitution step, I don't care, skip my substitution step. Okay. And then lastly, just one sort of applied problem. So one thing that's different on this quiz you're going to have Friday versus the last quiz is that this quiz actually has a calculator part. Like I'm going to have you do a complicated quadratic formula where you have to use a calculator to get a decimal answer. Does that make sense? So make sure you bring a calculator. Half of it is no calculator, and then there's 2 questions that you can use a calculator on.
Only 4 questions.
Oh, by half, I mean like, you know, one part is like 80%, the other one is 10%. So no, it's not only 4 questions, it's 10 with parts. It's like 20. All right, so the hypotenuse of a right triangle is 12 inches, and the area is 24 square inches. Find the dimensions of the triangle correct to 1 decimal place. So you have some triangle, you don't know if it's right, you just know you have a triangle.
Maybe that's right.
Oh, you do know it's right. Oh, thank goodness, that's very helpful. Why am I so, I don't know, is it still before 8 o'clock? No, it's not. I have no excuse.
It actually wouldn't matter if it's right or not.
I think it does because you can't get the equations that you're going to need otherwise. You need to use the Pythagorean theorem. So
Yeah,
there we go.
I was just thinking of the area.
Exactly. No, that's what I was thinking of too. Okay, so we know it's a right triangle. Thank goodness. The hypotenuse is 12. And the area is 24. Do we know that those 2 sides are equal to each other? I don't think so. I don't think it tells us that. Not necessarily, right? Some right triangles can have like one longer side than the other side, right? So I'm going to call one side x and one side y. And this is something where I think your book does something a little bit too soon. They haven't taught you the substitution method yet, which we'll sort of discuss briefly. I think it'll make sense. Okay, so from that picture, does it make sense that, first of all, from the Pythagorean theorem, x squared plus y squared has to equal 12 squared? Okay, so you've got x squared plus y squared equals 144. That's something you know. But you can't solve an equation. You can solve an equation for y or for x, but that's not really helpful, is it? Okay. Now you also were given some more information. What other information were you given?
The area.
The area. And so how do you find the area of a triangle?
X, Y divided by 2.
So 1/2 xy. And the area is 24, so 24 equals 1/2 xy. Does that make sense? Is that okay? And so you got 48 equals xy. Is everyone okay with those two steps? Okay. I think the easiest way to do this is to somehow put these two equations together. So I'm sure you've seen this before. The second equation, can you get one of the variables by itself? Either. Let's get the y by itself. So y would equal 48 over x, right? Does that make sense? And then this 48 over x, that can go in for the y, as in it can replace it. That's called substitution. Have you seen substitution before? Yeah, okay. So that's x squared plus the quantity 48 over x, the whole thing squared, equals 144. And now you've got one variable and you're good to go. Other than the numbers kind of suck. Okay, so this would definitely be a calculator question. X squared plus, that's 2,304 over x squared equals 144. Anybody have a question about this? Are we good so far? Yeah.
Couldn't you have just like square rooted both sides?
Couldn't you? Oh, great question. No. So you want to say the square root of x squared plus y squared equals the square root of 144, right? Okay, what you're trying to say there, and then what you want to say is that x plus y equals 12, right? Okay, that's wrong. All right, it's okay, because it's a really common mistake, and it's really good to point it out. Square roots don't distribute. Remember how powers don't distribute? And a square root's a power, it doesn't distribute. You can prove, if you try to use that as a rule, like the whole world falls apart, and you can prove, like, here's a really good example. So 9 and 16. How does PEMDAS tell you to do that problem? Tells you to add first, right? So you get 25, and then that roots to 5, right? If you try to apply that square root rule, you get root 9 plus root 16, which is what plus what? And so does that equal 5? No. Which means that the rule that you tried to use is not a rule. But it's a really, really common mistake. Like, it happens to calculus students all the time. One thing I'll give you at the end of the semester is I have this great packet that somebody wrote up where they were a little bit ranting about mistakes that calculus students make, things that they think are true that are not. And so hopefully, like, seeing that at the end of the semester will help you not make those mistakes. But it's really common, so it's good to discuss it. Okay, so moving on with this equation, since you have a fraction, how might you deal with it? Get a multiply by x squared. Does that make sense? So I can just take this whole equation and multiply by x squared. It's going to be the same thing as getting a common denominator, right? So it's going to be x to the 4th plus 2,304 equals 144x squared. Is everyone okay with that? And then minus the 144x squared, and you get x to the 4th minus 144x squared plus 2,304 equals 0. I don't think this factors. Yeah, it does not.
Be very cruel.
it'd be very cruel if it did. Well, it's pretty cruel as is. So to solve this, you have to use the quadratic formula, but technically the quadratic formula works if you have x squared and x. Does that make sense? So make a substitution and let u equal x squared. Then this becomes u squared minus 144u plus 2304 equals 0.
But the exponents don't matter with the quadratic formula.
Well, they kind of do, actually.
Your
So
numbers don't change though.
if they definitely do. I mean, they do matter, because the reason that you can solve this using the quadratic formula is because you have this like 4-2 pattern. And so it isn't like whenever you have three terms added together, the quadratic formula applies.
Well, yeah.
And technically, no, let me finish the problem. I'll show you why it actually matters, because technically the quadratic formula solves an equation that is ax squared plus bx plus c. It depends upon the fact that it's squared, first power, and a constant. And so if you are clever enough, you can make it apply to problems like this one. And then so when you solve this equation, the thing you have is x equals negative b plus or minus square root of stuff, right? And so the fact that this is x depends upon the fact that that's squared first power and no power. So before you apply that formula, you have to have squared first power, no power. And I think that's the easiest way to do it for now. Okay, so using that, we'll get u equals 144 plus or minus what comes next in the quadratic formula. Whatever 144 squared is, right? Minus 4 times 1 times 2304 all over 2. I am just going to tell you what I got. I got u equals 125.66. And I got u equals 4.12. No, that's wrong. 18.33 is my other one. I think if you had a calculator and had enough time, you could figure out that that's what those two answers were. Now, are those actually your answers? No. You've got x squared equals that thing. And you have x squared equals this thing. So in this case, when I square root sides, both of them, I'm not going to actually give a negative answer. So this first one is 11.2 approximately. And the second one is approximately 4.3. That makes sense. So those are the two sides of your triangle. Why wouldn't it make sense to do plus minus?
Because you can't have a negative distance.
You can't have negative lengths of sides, right? Okay. And this thing actually gives you both sides at once. Like the first x is one of the sides, the other x is the other side, because the order of the sides doesn't matter. So now Cole was saying, well, the quadratic formula, still applies because the numbers don't change. And technically, if you don't want to substitute, what could you write there instead of u that would make the quadratic formula true? You could write x squared equals. That would be okay, as long as you write the right kind of thing equals, right? That's fine. But if you wrote x equals, that would be wrong. Does that also make sense? Okay. So, I mean, for me personally, I have a really hard time doing things differently when I often do them one way. Does that make any sense? So it's easier for me to substitute and say, okay, it's just u, and then go back to x squared for stuff like that. Yeah, Tani?
So we stop there, we don't need to solve for y.
Well, if you do, let's just do it to show you what happens. Y would equal 48 over 11.2, right? I am almost 100% certain that's 4.3. Does that make sense? That seem plausible?
Okay.
So it just turns out that in this particular case, the second variable given is the one you need.
It doesn't always work like that?
In problems like this, it will. So I'm not sure how the textbook wanted you to solve this without knowing substitution, because they haven't really taught that to you yet. I'm not sure what they were thinking. Like technically those mixture problems that you guys like had on the homework from section, what was that, 1.1 perhaps? You did eventually, I think that was section 1.1. Those also are better solved this way. So we'll get to it eventually. Okay, so that's it from this section, right? All right, stop.